Good morning, folks. Welcome back to term 3. Today we're going to be starting off with exercise 6A, which is our new topic, ratios and rates. Apologies I wasn't able to be with you guys today. I'll be back tomorrow. But with today we're starting off with 6A, introducing ratios. I'll give you guys 2 minutes to write down the learning intention and success criteria in your books, please. Okay. Thank you. Welcome back. For today, we have our learning intention, and that is to understand that ratios show a relationship between related quantities. And the success criteria is I can write a ratio from a description and produce a ratio that is equivalent to a given ratio. So firstly, what we'll do is we'll think about, or we'll have this exercise to think about as an illustration. So when making a cordial, it is recommended that for every 1 cup of cordial, you add 3 cups of water. So you write it as ratio of 1:3 or 1:3. Okay. And just like it has here on this cup, or this measuring jug, we have 1 cup. So the green would be representing the cordial. And then over here, this would be the water. So water and then cordial. Right. So we have 1 cup of cordial is to 1, 2, 3 cups of water. So that's just the illustration that we have. And then for here, we're thinking if I had 2 cups, how much should I add according to this ratio? So if I have 2 cups, let's go here. If I have 2 cups, right here, I'm timesing by 2 because I've basically doubled it. So 1 times 2. And what I have to do on the other side is also do it by the same amount. Very similar to fractions. So 2 is to 6. So if you have 2 cups of cordial, you need 6 cups of water to keep to that same ratio. So it's not too sweet, but it's also not too diluted. Okay, we'll move on to the bound reference notes. I'll get you guys to pop this into your bound reference, please. So the ratios, they show a relationship, so that's the key word there, between 2 or more related quantities. For the meantime, we are going to be focusing on 2, but you can do more than 2 quantities. So, for example, this is what we talked about with the cordial illustration just before. The key thing that you need to understand, though, is this colon. That is what's representing the ratio. So, whatever it is on one side is related to what it is on the other side. So, when we have A, B right here, A colon B, you read it as A to B or A is to B. So on this situation here, we say 1 is to 3 or 1 to 3. Okay. The order in which the quantities are written is important, and the quantities must be expressed in the same unit. So when it talks about 1 to 3, it means this is 1 cup. And also 3 cups. So the units that are being used are cups, so they are the same. So that's probably right here. The quantities must be expressed in the same unit. That is very key right there. All right. Next is we're talking about equivalent ratios. So if each value in a ratio is multiplied or divided by the same number, an equivalent ratio is formed. So very similar to the fractions when you have equivalent fractions. So if you times the top by the top and bottom by the bottom, or divide the top by the top and bottom by the bottom by the same number, then you are going to get equivalent fractions. So for here, we have 1 to 3 is the same as 2 to 6 and same as 10 to 3. So if we think about it, how did it get affected? We did with this one here, we times both by 2, and with over here, oops, a little bit too much with the line. With here, we did times by 10, because here we did 1 times 10, and that's 10 here, and then 3 times 10, and that's 30 there. So those are equivalent ratios. All right. All right. I give you guys just the 2 minutes to write that down in your bound reference. So just take a pause right here. Okay, welcome back. Now we'll go into the worked examples. So the step-by-step that we have is we first need to identify the order of the quantities and then write down the quantities in, write the number of quantities in, including the colon to separate them. So what I'm going to do, what I suggest that you do whenever you do these word examples or word problems, just underline or highlight the key words or the key terms that we have, or the key information. So then you know how to put them into the correct formula or the correct expression. So the first one that we have is a sample of mixed nuts contains 5 cashews, so that's important. 12 peanuts, that's also important. And then 2 macadamia nuts, that's important. All right. So what we need to do now is write down the ratios of cashews to peanuts. So we need to remember, okay, where are the cashews? The cashews are here. So there are 5, okay? And then peanuts, okay, peanuts are here. How many are there? There are 12. And then macadamias, how many are there? There are 2. So the ratios of that, so notice there are now, oh my gosh, we went straight into 3. All right, it's going to be 5 to 12 to 2, okay? So remember on here, it talked about the order of things. So we know that this is cashews, this is peanuts, and this is macadamia. So 5, 12, 2. That's going to be the ratio inside that sample of mixed nuts. The next that we have is cashews to the total number. So cashews, we know that we have 5. And the total number was, we just add all of them up together. So 5 plus 12 is 17, plus 2 is 19. So there are 19 here. So it's just going to be 5 to 19. All right. And then lastly, the ratio of peanuts. So peanuts is here. So 12, there are 12 peanuts. And then the other nuts. So how many are the other nuts? So we have 5 cashews and 2 macadamia. So there are only 7 there. So it'll be 12 to 7. Yeah. I would recommend for you guys to maybe write down on the top where we have the words, just so that you're not thinking too much inside of your, or you're not holding too much information inside of your brain while you're still getting a grasp of this. So I'll give you guys a minute, or 2 minutes to do the you-dos there for me, please. All right, welcome back. So on here, we'll underline as usual what the key information is. So in a bag, there are 3 green marbles, 7 blue marbles, and then 6 red marbles. So the ratio of green, actually I'll use blue colors here just so then it's different. So green, there are 3, blue, there are 7, and red, it's up here, there are 6. So that means the ratio is going to be 3 to 7 to 6, okay? So that's the ratio that we have inside the bag. Next, it's the ratio of green marbles. So we know the green marbles up here, that is 3, and then the total, it's going to be total number of marbles. So 3 plus 7 is 10, plus 6 is 16. So total is 16. That means the ratio is going to be 3 to 16. All right. And then last one, we have the ratio of blue marbles. So we know the blue's up here, that was 7. To the other marbles, so we're just adding the other 2 marbles. So 3 plus 6, that is 9. So the ratio is going to be 7 to 9. Great. So just tick that if you have it. Otherwise, I want you guys to correct that for me now, please. Okay, we'll move on to the next worked example. So now we are going to be making equivalent ratios. So very similar again to what we were doing in fractions, right? So equivalent ratios mean that you are going to be multiplying or dividing by the same number. So the step-by-step is identify what the quantity has been divided or multiplied by. So you have to find the number that you already have, and then you find what it's going to be divided or multiplied by. And then you need to multiply or divide the other number that you don't know by the same quantity. Okay, and then of course write it down write it out here. So for here, what I know that we have is, so from 4 to 6, see how this is on the left side? That's also on the left side. That's why it's very important to have the order correct, because they are all representing a certain piece of information. So here it's 4 of something, it turned into 16 of something. So how do we get from 4 to 16? Either multiply or divide. We multiplied that. So we multiply that by 4. Okay. I'm actually going to rewrite it this way because I think this is going to be a better way to write it. So it's, 16. And then what we don't know, so I'll get rid of this. So how did we go from 4 to 16? We times it by 4. So that means on this side, we have to times the 9 by also 4. So whatever you do on one side, you must do to the other. So 9 times 4, that is 36. Okay. Very similar on this side as well. I'll get rid of, this. Oh, wait, what did we have? My bad. Oh, it was 5. Okay. So here we don't know what is on the left side, but we do know that it is a 5 on the right side, okay, afterwards. So on this side, how did we go from 15 to 5? It's not timesing, it is dividing. So it is divide by 3, not 5, sorry, by 3, okay? So that means on the other side, I'm going to also have to divide by 3. Cool? So 30 divided by 3 is 10. So those are the equivalent fractions that we have. I'll give you guys, should be a minute and a half to do the U2s on this side, please. So we'll take a pause there. All right, welcome back. I hope that you guys all rewrote it like this as well, just so then you can see very clearly what each side is. So on here, I keep forgetting to write it down first. So it should be, so it was 9, and then we don't know what the 10 changed into just yet. Okay, so on this side, to go from 3 to 9, we're timesing by 3, which means we have to times by the other side by 3 as well. Whatever you do one side, must do to the other. So it's going to be 10 times 3, that is 30. Great. I know that's, okay. So on here, this is going to be a 4, so we don't know what that is. So how did we go from 20 to 4? We had to divide that by 5. So whatever you do one side, must do to the other. So also divide, my pen is pooping itself. There you go. Good. Divide by 5. So it's going to be 30 divided by 5, and that is 6. Oh, come on now. Cool. Oh, that does not look like a B. Oh, that looks like a B. All right, that's a 6. You guys know that. Keep in mind, though, when you have a look at these ones, these are not the most simple ratios that it can be. Because when you think about it, with this right here and this right here, there's a number that can still go into 6, a number that can go in 4, like both, a number that can go in both 6 and 4, and on this side, a number that can go in 5 and 10. But we're not thinking of that at the moment. So for example, in this situation, it could be like, all right, I want to have 6 cups of flour. How much sugar do I need? So I need only 4. So it's fine to keep it like this unless they tell you to simplify it to the most simplified. All right, that is it for today. This is the log sheet for you guys to complete. As per usual, I need everyone please to complete at least these 2 right there for me. And then if you have capacity, challenge yourself to complete the preparing for year 9 as well. That's it for today. I will see you guys tomorrow. Take care.